Let's get this show on the road. Hello, everyone. Hope you're well. Welcome to another edition of Math 1108. Hope you guys are doing well. Let's actually just jump into it. Okay, there we go. So we'll start, I think, before the recap, is to start with some announcements. I know finals week is coming up. It's a crazy time for everyone, you guys as well as myself. So I have some announcements here just to make sure that as far as this class is concerned, we all kind of know what's going on. So I just want to bring some things to your attention. So we're going to start class with some announcements. In terms of what you need to know about today, test 2 is up to everything between the last test and probability, which means it includes like sets, counting, and probability. Although I won't ask much about sets in test 2, I don't think. I'll probably ask about sets, things like Venn diagram in a final though. But you'll know about what I'm planning on doing. So it's counting and probability. It's pretty much what it's test 2 is going to be about. There is a mock test set up. So that was posted. I also put the answers on the website, I think. I know I definitely typed the answers up. Did I post it? One of you can check and let me know. If I haven't posted, I'll post it at some point after class. So a mock test is posted for you to just kind of feel what the test would feel like, as well as practice uploading, make sure that everything's going to be fine. Okay, so in terms of that, that's something that you would want to do today. The mock test will be open for the next 24 hours-ish from now, 25 hours, right? So it's going to close at 10:30 a.m. tomorrow. So you have any point during the day to actually look at the mock test, try it out. And I think I set it for an hour plus 15 minutes upload time. So that's your goal. I think I set that time. Now, also today, written projects are due. You should just email me that stuff before midnight. So you email me the PDF or Word doc of your project, and you email me separately, like the Excel file, or if anyone used Python. I don't think anyone used Python. Whatever program or your data set, whatever program you use that in, you should upload that file as well. And yeah, that would be the written project. Tomorrow, we're doing our presentations, and that's all you have to worry about. So we just have 2 presentations and then we get out of here. I don't want you guys stressing about anything else. So tomorrow's lecture is actually going to be recorded asynchronously. Technically, I could have finished it after the presentations, but I don't want to push it. So tomorrow you'll be doing your presentation. So you'll come together as a group. You guys should all be able to share your screen, able to use your camera probably. So I will be recording it, but I won't be posting that publicly, of course, but I need to record it so that the coaches can judge the presentations. So that will be happening, and that's tomorrow's class. After that, so you'll have an asynchronous lecture that day, which you can probably watch after that day. But also the actual test 2 would be posted, and that you will also have a 24-hour period to actually do. So the test 2, I believe it was set to come live at 10:30 a.m. So right after the class, and it stays open until 10:30 the following day. However, once you log in at any point during that period, you'll only have a set amount of time to finish the test, but you can choose what time you're going to do the test over that 24-hour period. As for finals week, we'll sort of play it by ear. There are a lot of things that I would have to do in terms of scheduling. Like if I wanted to set up a review session, I would have to find out from you guys when most people would be available for a review session, etc. So just keep a lookout for any announcements from me, whether it be through email or Jupyter or something else. Or I might send out a doodle poll or something just to see where most people are. And yeah, so those are the announcements. So important things for today: finish up your written project, email that to me before midnight. And at some point today, you want to do the mock test, because that will help you prepare for the regular test. So you already did the homework, so you've gone through a bunch of different sections, but now to just kind of focus on something, the mock test will help you focus. And it's going to be, like I said, it's on probability, everything about probability, from the basics to conditional probability to Bayes' theorem, to all that, independence, and are the homework modules due tonight? I think everything up to probability is due tonight. Like, I wouldn't make the statistics due tonight. So if it is due, I'll push that for sure. But you should cover the probability up to tonight, because that's how you're going to prepare for the test. That's one of the preparations. Yeah. So that's where we are. So if there are no more questions, we will go back to statistics, which, as I mentioned, we're not going to do a lot on. Our syllabus just doesn't have a lot on it. And in fact, our syllabus stops at a weird place for me. So the last thing I'm supposed to talk about with you guys in statistics is the binomial distribution and Bernoulli trials, which a binomial is just a combination of Bernoulli trials. But I already told you guys about the binomial distribution. I'm not sure if I'll talk about it again, because the point of the binomial distribution in statistics, what it's really useful for, is to approximate something like a normal distribution, which we don't talk about. So I'm not exactly sure why that was left in the syllabus without you seeing why it would be useful in a statistics context. Yeah, so we'll talk about things like the charts that you want to do in statistics, measures of averages like mean, median, mode, and we'll talk about measures of variation like standard deviation, and we'll talk about why these things are important, what they're for, and yeah, that's pretty much it. You would have used some of these ideas in your projects, but as you'll see, they're not particularly complicated ideas. You just had to look them up. But yeah, that's where we are. So I started talking about statistics. It's just a way for us to collect, organize, display, analyze data. And the point of doing that is to be able to answer questions for which we don't really have any other good way of answering them. Like, the question isn't governed by some mathematical formula that we can just plug in and calculate. It's things like, oh, is smoking bad for you? Or how long will I live? Or blah, blah, blah. Like, there's no equation for any of these things. And there's no certainty in any of these things either. So accidents happen, freak accidents happen, phenomena happen. So nothing is guaranteed. And so it's a very weird thing to actually answer questions about this. But it's also important for planning purposes. So statistics comes in there. So statistics, you might get a mass of data and you want to start organize it so you can talk about it. And one way to do it is in a table, talking about frequency, look at the different types of data points, how often do they show up. You might want to answer more information. So we have things like relative frequency and cumulative frequency. So relative frequency tells us about the proportion of times something might happen. And cumulative frequency tells us about the proportion of the number of times something at that level would happen or higher. So that's what the cumulative frequency is about. And so you can create a table with more data and you can answer more questions, because collecting data and organizing the data to be able to answer questions about the data and what it implies is the point, right? So you can have that. But eventually tables can get huge and cumbersome. Just like with your projects, you guys are dealing with tables with like hundreds of rows. Like if you're doing like the Premier League, Final Fantasy, that had like 680 something rows or something in the typical table. So that can get very cumbersome. You can't like do a PowerPoint presentation and expect your audience to just really absorb 680 rows of data. It's not going to happen. So that leads to charts and graphs, where we can draw a picture of the data, right? So that's much more visceral. You can talk about the data a lot quicker and a lot easier. You can kind of see where most data points are, roughly estimate some sort of proportion. And it's not super accurate, when you are eyeballing stuff, but you can get an idea, and you might want to know when you want to zoom in on something. So if you see, okay, you actually care about this right here, what you can do is you can just go up to the table for that row and examine that row. The picture actually can indicate where you want to focus your attention. Okay, so that's useful. So that was the only actual chart we did. We're going to do some other charts now. So after the announcements, what I want to talk about is the pie chart. Now the pie chart is, it's not something I'm ever going to ask you to do, but it is a very common way to display data. So I'm just going to tell you about it. But because it's very hard for someone by hand to accurately do a pie chart. Like you'd really need like a protractor and like a compass to draw a circle. It's kind of weird to ask you about it. Different people would draw pie charts and they'd look radically different, yet everyone can have the same interpretation. It's very hard to grade. So I'm not actually going to ask you to draw a pie chart, but you should know what they are and how to construct them. So let's start by talking about that. So pie charts are also used for qualitative data. Which is also something we spoke about. Remember, qualitative versus quantitative. Qualitative is data based on things like categories or types or names or qualities, whereas quantitative is based on numerical data. So numerical grades, heights, lengths of stuff, average cost of things, things like that. Whereas your qualitative data is categories like letter grades, names, brands, rankings, things of that sort. So a pie chart is used for qualitative data. So you're plotting things about categories or types. Okay, so now it's basically, it is a circle sliced like pizza slices into sectors based on relative frequency. And if you want to know like how much the central angle of a slice is, the central angle of a sector is computed by relative frequency times 360 degrees. Right. So at some point you probably learned in high school geometry class that a circle has 360 degrees, blah, blah, blah. So you have a bunch of degrees. A circle is sliced up into 360 equal components. The angle of each component, which is the kind of distance between the two lines, is a measure of degree. Right? Well, the circular distance between two lines is a measure of degree. You can also have radians, but they usually use degrees for context like this. So you do that, and you can figure out how to draw this graph. So example, for the above grades. Okay, so these same 15 grades that we were looking at last time, you can have a pie chart. So remember, every good chart has a title. So pie chart showing the letter grades of the class. Okay, so that's the title. And the pie chart is, like I said, it's going to be a circle, which I'm not even going to attempt to draw that by hand. Okay, so it's going to look like that. And you're going to slice this circle up. So a pie chart also tends to have a key that helps you read it. And I'll do that a little bit more. Basically, it's going to identify the categories that you care about. Which for us, there were 5 grades, A, B, C, D, and F, right? And so you have the key that tells you how to read the pie chart, which slice refers to what. And the pie chart might also on itself have labelings. So you can have, for example, the center is going to be like here. And you know that if you look back in the table at the relative frequencies, A's happen 20% of the time, B's happen 20% of the time, C's happen, F's happen 20% of the time, C's happen 26.67, so slightly more, D's happen 13.33, so less than 20%, but these are the things you're going to plot. So 20% is about 1/5, which again, by hand, it's not going to be something that you'll be able to do super accurately, but we'll try. So that's going to be like here maybe. Okay. So that's like your A, right? So this is A. And I can do like the B is here. And I can do like a C like that. Let's put in the C. That's a little bit more than 1/5. And I can put in D. And I can put in, say, an F. Right? And so you can kind of see proportion-wise how things would actually line up. Of course, it's very hard to read without any labelings. So people tend to label their pie charts even further. So they would say, okay, A here is 20%, B 20%, F 20%, C 26.67%, and here you'd have D 13.33%. Okay, so you can label the chart like that. And that is basically a pie chart. FYI, if you're looking at this, an angle, say you have this angle over here, call it theta, you can compute theta. Like what angle you'd have to do is you can compute theta. So FYI, theta would be equal to 20% of 360 degrees. So that's going to be 0.2 times 360 degrees. That's going to be 72 degrees. Right. And so that angle here is 72. The B, the angle would also be 72. The F, the angle would be 72. Do a similar calculation and you can figure out the angles for the C and the D, right? So you'd multiply 0.2667 times 360, and that's going to be the degree angle for the C. Multiply 0.1333 times 360, that's going to give you the degree angles for the D. And yeah, that's a pie chart, right? But it's very wonky to do these by hand. So I'm never actually going to ask you, but it's a very common thing. And it's in our syllabus guide to tell you about it. So I'm telling you about it. Moving on to something that is important, a histogram. And this is used for, someone's coming in here. This is used for quantitative data. It's the quantitative version of a bar graph. Right. So we looked at bar charts last time, which was a quality diagram. It graphed categories versus relative frequency. If you have numerical data, you don't do a bar graph or a bar chart, you do a histogram, as we call it. So this is for qualitative data. Now, when we are doing this, this is for quantitative data, that means numerical data. So if I'm not looking at letter grades like A, B, C, D, but I'm actually looking at the numbers in a grade, like a bunch of this, like, so here are the grades of 20 students and they're numerical values, right? So I didn't classify them as A, B, C, or anything of that sort. I tell you the actual numbers, right? Now, if I wanted to graph that in a kind of bar graph-esque kind of way, what I would do is I would create what's called a histogram, right? Now, to create a histogram, you usually create something that's called bins, right? Which is ranges of values that we care about. So we do actually put values into ranges. So you're not going to draw a bar for each numerical value as you would with a bar chart, but you put in ranges of numerical data and you group those guys into a sort of category, and then you graph the bars over there. Okay, so you'd first create bins, and so when we have the data here, so this is our data now. What we're going to do is we're going to have to create a histogram based on this data, and I'm going to show you how to do this. By the way, the one part of the bonus problem for the test and a part of the bonus problem that you'll see on the mock test is to create a histogram. So this is something that you should know how to do. So this is relevant as more than just an example. It's a way you can get some extra points if you pay attention to this. So yeah, you'd first make a frequency table for the bins of your data. So that's the first thing you want to do. Okay, so what would that actually look like? So we have grade. So here you have grades, which I'm going to use as the bins. I'm going to start grouping grades. Then I'm going to have the frequency, of course. Now, the only reason why I care about frequency is because I want to actually get to the relative frequency. Right? So a histogram is going to plot histogram plots bins versus relative frequency. So these are the two important columns for a histogram. So how do you actually go about this? Well, first of all, the bins are going to, usually the person doing the chart chooses the bins that they think would be useful or relevant. Often they're chosen to be of equal widths. Sometimes they'll be given to you, like in an exam. Chances are I would tell you what bin lengths I want you to use. And so let's say we're grouping the grades based on lengths of 10 units, right? So if I look at the grades here, I would notice there isn't really any data points below 50. I have data points in the 50s, right? And the data points increase going all the way up to in the 90s. But there's no data point below the 50. So I might start measuring my ranges starting from 50. And I just might decide, for whatever reason, to go by tens. So I could do a bin like including 50 up to 60, not including 60, including 60 to 70, 70 to 80, 80 to 90, 90 to 100, right? Here's the total. I know there are 20 grades, so the frequency should add up to 20, and the relative frequency should add up to 1. We spoke about that last time. And so you or a computer would actually go through and count how many things are in each bin. So how many grades are between 50 and 60? So I would go off and I'd count, okay, so 57 works, 51, 54. That's it, there are only 3, right? So I would go, and the frequency here is 3, right? And you do the same thing for the rest, right? So if you go here and you count all the things between 60 and 70, all things between 70 and 80, between 80 and 90, between 90 and 100, take my word for it, you will get this many things. There will be 6 things in this range, 5 things in that range, 4 things in this range, and 2 things in that range. And so here you end up with the 20 things. Okay. Then you want to compute relative frequency. Now remember what relative frequency is. It's just the frequency of the individual data point divided by the total number of data points. So over here, I'm going to take 3 divided by 20. Right here, I'm going to take 6 divided by 20. Here, I'm going to take 5 divided by 20. Here, I'm going to take 4 divided by 20. I'm going to take 2 divided by 20. Okay, so here, this would be 0.15 or 15%, 0.3 or 30%. This will be 0.25, 25%, 0.2, that's 20. And here I'd have 0.1 or 10%. And that adds up to 1 or 100%. Yeah, and that's our table. So you go through each frequency, divide by the total number of things there are, that gives you the relative frequency. Okay. And now once we have that, we can actually do our chart. So remember, a good chart always has a title. So I'll start by putting in my title. So histogram showing the grades of the 20 students. Okay, so there's my title. I don't know why. Okay, so there's my title. And the setup is going to look very similar to a bar graph. So on one axis here, I'm going to be plotting relative frequency. And on the other, I'm going to be plotting the grade ranges. Okay, so, and now I know the frequencies. We had 0.1, we had 0.15, we had 0.2, and we had 0.25, and we had 0.3. Okay, then on this part, you're going to put the bins. We had 5, 1, 2, 3, 4, 5. So I'm now going to label these guys. So this guy is going to be the 50 to 60 range. Here we're going to have the 60 to 70 range. Here we're going to have the 70 to 80 range. Here we're going to have the 80 to 90 range. Here we're going to have the 90 to 100 range. And now I just draw the bars for each one. Typically what you'll see in a histogram, and this is typical, I mean, you should be able to tell a histogram by a bar chart by what kind of data you're plotting. But typically in a histogram, you won't have spaces between the bars, where in a bar chart, they'd usually put spaces between the bars. So for example, 50 to 60, we had 15% there. So there's that. Between 60 and 70, we had 30%. Then between 70 and 80, we had 25. Then between 80 and 90, we had 20. Then from 90 to 100, we had 10%. So this is down here. Right. And of course, you can color this. You can make it look fancy. Do your thing. And that's your histogram. Couple comments here. Typically, no space. Between the bars. Whereas with a bar chart, spaces between the bars. But still, even if they follow the spaces rule or they don't, you can still tell a bar chart from a histogram by just what you're plotting against. If you're plotting against categories, qualities, it's a bar chart, whether or not it has spaces. If you're plotting against numerical data or ranges of numerical data, it's a histogram, whether or not it has spaces. But these are some typical practices. Another practice is that sometimes you might label a bin based on the middle value in that bin. So I should mention that sometimes bins are labeled with the middle value in the bin. So sometimes you'd actually see a bar chart where they only have like one thing here. So they probably put like a 55, a 65, a 75, an 85, and a 95, right? And they would just label it with that. They would label it with one number, but it's understood that that number is just the middle value in some range. It spreads out to a little to the right and a little to the left of that number. And you can kind of figure out how much it's spread by looking at the distance between the values. The distance between 55 and 65 is 10. So we know that we're using a width of 10 units for each bar, right? So I know from the 55, I go 5 units to the right, 5 units to the left, okay? So sometimes they might do that for aesthetic reasons, or there's no real mathematical reason to do it that way. So yeah, you have that. Now, from a histogram, we can get something called a line graph. Now, let me show you how to create that. So here I have my histogram. Okay. So how you can create a line graph is what you do is at the top of every bar in the middle, you put a point. So I would have like a point is here, and then there's a point here, and there's a point here, and then there's a point here, and there's a point here. The starting points are usually the beginning and the end of the data set. And what you do is you just connect these with straight lines. So you'd have a straight line connecting those, straight line connecting those, straight line connecting those, straight line connecting those. Right? So here what we do is put a point at the top and middle of each bar, and you would connect successive points with line segments. Right? And what that does is well, I'll talk about this in a little bit. So this leads to, so these are, again, the grade ranges. I'm going to want to copy this. So this leads to something like this. So I can do a line graph here. So this is a line graph of the 20 grades. It's my title. And here you just kind of ignore the bars and focus on the line. Right? And there you have a line graph, right? So you just have this curve that represents what's going on with your data. Okay. Now this, of course, can lead to something called, well, I don't know if of course was the right word to use there. From this is one way in which we can use this. From a line graph, you can get something called a frequency curve or a frequency polygon. So a frequency curve is pretty much exactly the same as a line graph. But when we say frequency polygon, that's when we're thinking of it as some sort of 2D figure, right? Because that's what a polygon is. I don't want the title. I'm gonna make a new title. So this would lead to something like this. Okay, where I can have here frequency curve or frequency polygon of the 20 grades. Okay. And what that does is it really focuses on the actual 2D figure. So you can think that there's a line here, 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 there's the base. And you sort of think of this as a 2D figure. And that leads you to the notion of, oh, there's a polygon that's associated with this data, right? Which is just a geometrical shape that's closed and it has straight lines on its edges, right? And it would look something like that. So that gives you like a frequency polygon. Okay, now frequency polygons start to give rise to a shape. So now you have a shape that goes with this data. It looks like this mountain right here, right? And different data will have different shapes to them. So this leads to the notion of a shape. And then we want to know about things that we can talk about based on those shapes. So that leads us into the next section, which talks about central tendency and averages, right? So you'll notice that the frequency curve of the example in the last section, it gives you a shape. And there's something that you might notice about it is that it has a peak. There was actually a highest point, right? Like there was a summit, right? So there's a highest point right here. That's the peak, right? So that's something you might notice. And why might you notice that? Well, that kind of tells you where most things are, right? So if I were to guess some random person, a random person going into this class, what their grade would be, I would probably guess, not knowing anything about the person or their preparation or how they're going to get along with the professor or any of that, I would guess you're probably going to get between a 60 and a 70, right? Now, I can't say that for sure because obviously people can get other grades, but it's clear that the range of 60 to 70 was the most common one here. And that is represented by the peak, right? And that value, the fact that you get something between 60 and 70, most likely is important because again, remember the point of statistics is to be able to answer questions generally, right? Might not be able to answer for every specific individual, but in general, overall, you'll be able to make a judgment call and be like, yeah, you know what? Most people in this situation, they're going to end up between a 60 and a 70, right? So that leads us to now the notion of central tendency and averages, right? So what the peak represents, it's a typical value. What typical means is that most values are like this, right? So most people in this class end up between a 60 and 70, and that allows you to make some sort of, answer that of course you have to qualify about some statistics. You can say things like, oh, is smoking good for you? Well, how do most people end up smoking 2 packs a day for 50 years, right? There's a typical value, right? Now, there's no guarantee that you would end up that way, right? You might end up better or worse than the typical value. But there is a notion of, yeah, most people end up this way. And so you might want to make your decision based on that. You're a human being, just like most people are a human being. And so this typical value can somehow represent an answer. Some people take it as the answer, but it's not really the answer. But it gives you an idea of what the answer is likely to be for you. And so that's a very important value. So that talks about central tendency of data. This is the tendency of data to clump up around some value or values. And these are taken to be the typical values. These are like the peaks and the mountains. Where do most people clump together? And those are the values you'd want to know. Now, to figure that out, we create a number called an average. And this is just a numerical measure of the central tendency. And I'm not sure why that's, I think I accidentally pressed an enter here. Let me fix that. Now, so in central tendencies, the idea of data to clump together at some point, this point is very important for us to know because it represents an answer. So how do we actually measure what the answer is? An average is what we use to measure what the answer is. It gives a numerical value to this answer, right? Now, there are many kinds of averages, right? There are many types. But three very, very common types of averages is the mean, the mode, and the median. And this is the only ones that I expect you guys to know about. And I'm just going to do some quick examples with them. So to talk about what they are, the mean is a very common measure of central tendency. In fact, it's so common that usually when people say average, they tend to be talking about the mean. So when someone tells you, oh, my average grade was blah, chances are in their head, they're thinking about the mean. They should by right say the mean, my mean grade was blah, but people just say average and everyone kind of assumes that you're talking about mean. It's because the mean is a very common average to use. It is an average that you're all familiar with. I'm sure when you're figuring out like what average grade in a class should be based on what you've been getting, a mean is something that you can do. What was your average test grade? So this is the sum of all the values in the data set divided by the number of values there are. Mode is a different kind of average. It's not defined by an equation. It's just like what value shows up most often. Just count who shows up most often. The median is another measure. And this is like the middle value, right? The value that shows up in the middle. Now, how you find that is you'd arrange all values in ascending order. It could also work descending, but we usually traditionally go in ascending order. And then you pick out the value in the middle, right? Now, if there's an odd number of values, like 5, there'll be one number definitely in the middle. So if you have 5 data points, the third number would be the middle data point. For an even number of values, though, the median is defined to be the mean average of the 2 middle data points. So you add the 2 middle data points, divide by 2, right? So for 6 numbers, for example, this would be the third and fourth data point, right? You would find the mean average of those data points, and that would be defined to be the median. FYI, it might seem strange that the middle value could be interpreted as a typical value, but there are situations in which this is the best average to take. You'll notice, for example, if you were to look up average salaries for a certain position or a career, usually they'll tell you the median salary. They won't tell you the mean or the mode, because it's not a good measure of what's typical. Because in, say, a company, you'd have like the interns and then the entry level people and then middle management and then executives and CEOs. And the salaries can vary so widely that if you were to take the mode to be a measure of the typical salary, you'd think everyone is making what an entry level employee is making because most of the people are entry level employees. So like $30,000 a year or whatever. If you were to take the mean, because you might have executives and CEOs up here, they're making like $2 million a year. When you take the mean, the value is going to be very high, like $1.5 million. But obviously, it's not typical to get $1.5 million in salary. So that would totally be off. The middle value is going to get you more typical. That'll end you up somewhere between like middle management and senior employees, right? And so they would use the median, right? And coincidentally, when a teacher is doing statistics for grades, the median grade is usually the better average to look at for how the class is doing. Yeah, so these are things that I think you guys have all seen before, so we'll just run through the quick examples. So to talk about the mean, you simply add up all the values, divide by the number of values. The mode is the guy who shows up most often. The median is the middle value. So if I gave you these 10 values here, you would have, if I ask you, what is the mean? Well, you're just going to add up the 10 values. Divide by the number of values. You will get 8.2 as the answer here, right? So that is just a measure to you of the typical value. I think my screen is frozen. I don't know what's going on. Hopefully it catches up. So I wrote mean equals 12 plus 3 plus 2 plus 15 plus 12 plus 9 plus 8 plus 12 plus 6 plus 3 divided by 10. I don't know why my screen is not catching up here. Anyway, the mode in this case, you'll see it in the notes. The mode in this case would be 12. And the median, you would first arrange these numbers in ascending order. So right in ascending order. So I would arrange these like 2, 3, 3, 6, 8, 9, 12, 12, 12, 15. The two middle values would be the 8 and the 9. I'm not sure why this thing is messing up. It's very freezy. Okay, so the median would be the average of the 8 and the 9. Okay, so now you can see the mean was just me adding up the numbers, dividing by the number of numbers there are. I get 8.2. The mode is 12. It's the guy that shows up. You could have several. So let's say another value showed up 3 times. I could say the modes are 12 and whatever that number is. The median, you can only have 1. It's an even number of data points, so I'm going to take the mean of the 2 middle ones. That's going to give me 8.5. So here you would get the median is 8.5. And these are just measurements of the typical values. And that's all I have for you today. So tomorrow's lecture, which is asynchronous, is going to talk about variation, standard deviation, spread, and why it's important, what it's used for. But for now, we will stop there. So we're like 2/3 of the way done with what we wanted for statistics, but we will end there. So have a good day. Good luck with the rest of your day and with the other stuff you have to do. And I will see you guys in the next one. Ciao.